Hi everyone. Today we are going to study the model driven approach for the development of an information system. In our previous video, we saw various approaches for development of information system, and the three approaches that we studied for the development of information system were the model driven approach, accelerated approach, and the joint application development approach. Now today, out of these three approaches, we are going to study the model driven approach in detail, and in the next two upcoming videos we will study the accelerated approach and the joint application development approach in detail. So basically we are continuing the previous video wherein we saw an overview of the three approaches for development of information system, and from today we are going to study each and every approach in detail. So the next upcoming two videos will also cover the remaining two approaches in detail. For today, we are going to cover the model-driven approach in detail. Now the model-driven approach is also known as the structured analysis and design approach. You can either call it the model-driven approach or you can call it the structured analysis and design approach. So the model-driven approach for the development of information system, what is this model-driven approach? Basically, when I say model-driven approach, that means I'm using models. I'm making the use of modeling. And what is modeling? Modeling is the act of drawing one or more graphical representations of a system. So basically in modeling, we represent the system graphically. We draw the graphical representation of system, and such a graphical representation of the system is known as modeling, which is used in the model-driven approach. Model-driven development techniques emphasize the drawing of models to help visualize and analyze the problem. So basically, how are we analyzing and visualizing the problem of the information system to be developed? We are visualizing and analyzing the problem of the information system through a model-driven development techniques wherein we are drawing models. Wherein we are drawing models which are basically graphical representations of the system. These models help us to visualize and analyze the problem. The structured analysis and design approach, also known as the model-driven approach, is basically a model-driven approach. That means you use models to represent the system. You use models to visualize and analyze the problem of the system. Now when I say structured analysis and design approach, if you look into the details, you will find it consists of two components: structured analysis and structured design. So if I break this into two separate components, one component is structured analysis and the other component is structured design. Whenever we are doing system analysis and design, the job of the analyst is to first analyze the system and then design the system. You cannot design the system without analyzing it. So the first phase would be structured analysis and the second phase would be structured design. So that means to study structured analysis and design approach, we must study both the structured analysis and structured design, where structured analysis would come first, and after we are done with structured analysis, we would do structured design. And basically, who is doing the structured analysis and structured design? The system analyst, because it is the job of the system analyst to analyze and design the system. Structured analysis. Now we will start with the first component, which is structured analysis. Structured analysis is a development method for the analysis of existing manual systems or automated systems. So basically, it is a development method What kind of a development method? Which involves the analysis of the systems. These systems can be existing manual systems or already existing automated systems. So it is used for both manual and automated systems which are already existing. We analyze such systems which are either manual or automated, and this analysis of the already existing manual or automated systems leads to the development of expected functionality or behavior from the proposed system. So whenever a new system is proposed from the already existing system, that could be either manual or automated, we analyze the already existing system, and from that already existing system, from the analysis of that already existing system, we find the scope for the development of expected functionality. Whatever the expected functionality or expected behavior is from the system that is proposed, that is found with the help of analysis of the already existing systems through structured analysis. The major task of structured analysis approach, if we look at the major task, there are 4 major tasks of any structured analysis approach. The first one is preliminary investigation. See, the sequence of the phases is very important here, and we have to perform each and every phase in sequence only. We cannot go out of sequence. So when seen in sequence, there are 4 major tasks of the structured analysis approach. The first task is preliminary investigation. The second task is problem analysis. The third task is requirement analysis. And the fourth task is decision analysis. So if we look at these in detail, we will see that basically preliminary investigation is the first task that is done. Preliminary investigation, it refers to the collection of information that guides the management of an organization to evaluate the merits and demerits of the project request and make an informed judgment about the feasibility of the proposed system. So basically here we are finding out how feasible the system is through the help of certain collected information, with the help of which we can find out what are the advantages of having this system and what are the disadvantages of having this system. And if the advantages outweigh the disadvantages, we can say that the proposed system is feasible and we can go ahead with it. So this is what is done in the preliminary investigation. Now there are various methods for preliminary investigation. One is reviewing the documents provided by the organization. Now the organization which wants to come up with a new system, which has proposed a new system, provides certain documents about the proposed system to the system analyst. So the system analyst would review those documents which are provided by the organization. Next, so basically these documents provided by the organization are quite effective in guiding the analyst towards visualizing the features that were needed to put together in the system and what would be the required output which had to be generated when the system became functional. The second technique, another important technique for preliminary investigation, is on-site observation. That is, the analyst goes on the actual site and observes things. So basically it is used by the analyst to gain information about the project by visiting the client site where the system has to be installed. So here a detailed system study is carried out, checking the existing system to replicate it with your proposed system. It is also the activities of the system are directly observed. The working of the people, the activities of the system are directly observed by the system analyst during the on-site observation. The environment of the office, the workload of the system and the users, the method of their working, and the facilities which are provided by the organization, these are all seen by the analyst. And this information helps the analyst to understand how the system should operate and during the on-site observation, the various employees are also interviewed who are directly affected by this system, so as to gain more insights about this system to be developed. The third method of preliminary investigation is conducting interviews. Now, when you conduct interviews, when the system analyst conduct interviews, he is basically investigating the various employees of the organization who will be using this system, and it involves questioning the concerned people or personnel to get the client view about the system and the features that they wish to have in the proposed system. Some of the questions here during preliminary investigation, during the interview session of preliminary investigation may include what is the amount of data that is needed to be stored, what are the number of customers using the system and number of which the application needed to be installed, the issue of the application with the existing system, like why are you proposing a new system and what is the issue of the application with the already existing system, level of access given to different people. All these things are discussed during the interview session by the system analyst. Then these are the three major techniques through which preliminary investigation is done by the system analyst. Once the preliminary investigation is done, next task is to do problem analysis. During the problem analysis phase, the system analyst examines the business problem. What are the problems of the business? Then what are the objectives of this business? And what are the requirements of this particular business? And then finding out the most or designing the most optimal solution to fulfill all these needs of the business. This is done during the problem analysis phase. Once the preliminary investigation has been done and the problem analysis has been done, the third step is doing the requirement analysis. That means what is the actual requirement of the business from this proposed system. And once the requirement analysis has been done, then the fourth step is decision analysis. In my previous video also, I told you that we do not just go for one solution, but we have several candidate solutions. The system analyst does not look for just a single solution. He looks for several solutions which are known as candidate solutions. Out of all those available solutions, during the decision analysis phase, the system analyst would select the most optimal solution for the proposed system. So you can say that the structured analysis approach, the structured analysis is a process-centered technique that is used to model business requirements for a system, a process-centered technique, and obviously it is used to model the requirements of the business for a particular system. You are intending to develop a new system for a business. So that means you have to model the business requirements for a system. Structured analysis introduced a process modeling tool called the data flow diagram, which is also known as DFD, and it is used to illustrate business process requirements. So basically, structured analysis introduced a process modeling tool, and this process modeling tool is known by the name of data flow diagram, which is also known as DFD in short. And these DFDs are used to illustrate the business process requirements. So that means they are helping us find out what are the process requirements of this particular business. How do you do that? By depicting the flow of data through the system. Whatever system it is, whatever the business system it is, what is the flow of data from where it starts until where it goes? That flow of data is shown through the data flow diagram or DFD. That is why we say that they are used to illustrate the business process requirements, because how would you illustrate the business process requirements? Through the flow of the data, which is shown very well through the data flow diagrams. With the help of the data flow diagrams or DFDs, the system analyst can show system overview. When you can show the business process requirements, or in other words, when you can show the flow of data through the system, that means you can very well show the system overview. So that is why we say that with the help of DFD, the system analyst shows the system overview. Apart from the process modeling tool called data flow diagram, another modeling tool, that is the data modeling tool, is used, which is known as the entity relationship diagram or ERD. Now kindly notice that there is a difference between DFD and ERD. DFD is also a modeling tool and ERD is also a modeling tool, but DFD is a process modeling tool which models the business process requirements, and ERD is a data modeling tool which illustrates the business data requirements, right? So with the help of DFD, you are able to identify the flow of data in the system, and with the help of entity relationship diagram or ERD, you are able to model the data requirements of the system. So DFD shows the flow of data, and the ERD or the entity relationship diagram shows the data required for the system, for the development of system. So precisely, in a gist, I can say that with the help of DFD, you are able to find out the process requirement of what all processes are there. What is the requirement of processes throughout the data, and that means what is the flow of input through the data. What is the flow of input through the data? That is depicted using the data flow diagram. And what all data would be required by the system is depicted using the entity relationship diagram. That is, it is illustrating the business data requirements. What all data would be required for the business is the job of illustrating is illustrated with the help of the entity relationship diagram, and what all processes would be required for the business are depicted or modeled through the data flow diagram. So the data flow diagram is telling you what all processes are required by the business, and the entity relationship diagram is telling you what all data is required for the business. So basically, when I say business, that means from the new proposed system. Once we are done with structured analysis, the next step is structured design. So we have done structured analysis through our two basic modeling techniques. One is your process modeling tool, the data flow diagram, and another is your data modeling tool, the entity relationship diagram. So with the help of these two models, the process modeling tool DFD and the data modeling tool ERD, we have done the structured analysis. Once we are done with the structured analysis, next we will do the structured design. The structured design uses graphic description. As I said that the model-driven approach uses graphical representation of the system. So whether we are doing structured analysis or we are doing structured design, everywhere we will use graphical descriptions only. The graphical descriptions used during structured analysis were the data flow diagram and the entity relationship diagram. Now once we are done with the structured analysis, and when we move on to the structured design, again the structured design also utilizes graphic description. And this graphic description is basically the output of system analysis. As I said that the phases are very much in sequence and you cannot go out of sequence. So it is only after structured analysis you can proceed on to structured design. You cannot do structured design before structured analysis. So the output of structured analysis, whatever is the output that has been achieved after the structured analysis phase, the structured design phase basically gives a graphical representation of that output derived from the structured analysis phase, and then it focuses on the development of software specifications. Once we get an output and graphically represent that output of structured analysis, then the focus during this structured design is on the development of software specifications. That means what all software would be required for the development of this information system. All those specifications regarding the software are done during the structured design phase. The goal of structured design is to lead to development of programs consisting of functionally independent modules that perform relatively independently of one another. So basically the goal of structured design is to lead to the development of programs. Obviously we are talking of an information system, so we are basically focusing on the development of programs, but these programs should consist of modules. When I say modules, basically these are smaller programs. Why smaller programs? Because the system as whole is very large and complex. So to cater to the problems of the system and to find the solution of the system, first of all we divide the system into various subsystems. Then it is easier to target the problems, small problems of each subsystem, whose solution would finally lead to the solution of the system as a whole. So when we divide the system into various subsystems, it is easier to deal with it. So these subsystems are basically the programs made for these subsystems are called the modules. And though these modules coexist in the same information system and they are correlated to each other, yet they are expected to be functionally independent modules. When I say functionally independent modules, that means the functionality of one module should not affect the functionality of other module, and both of them, and all those modules, despite coexisting in the same information system, must perform independently. That means they must perform independently of one another. Once the functionality in one module, the programs in one module, should not affect the functionality of the other module, and they should be relatively independent of one another. They should not be affected by each other. Only then they can perform well. The structured design approach only gives you the software specifications, but it does not specify the file or database design. What would be the design of the file, or what would be the design of the database, or what would be the layout of an input or output. This is not specified during the structured design phase, nor is the hardware on which the application runs is specified during the structured design phase. So you do not specify the design of the file or database, you do not specify the layout of input or output, nor do you specify what hardware will be used on which the application will run. The only thing that you specify during the structured design phase is what would be the software specifications, and you have to take care in mind that all the modules that are developed are functionally independent. So the structured design basically provides specification of program modules. What all would be the program modules? Basically the subsystems that we have divided from the system. The system, after being divided into subsystems, what would be the program modules for those submodules, and which are functionally independent, because we do not want the functionality of one module to affect the functionality of other module. They should work independently. So we can say that the structured design is a process-centered technique that transforms the structured analysis models into good software design models. So basically, the structured design technique is transforming the models of the structured analysis phase into good software design models. Structured design introduced a modeling tool called structured charts. So during structured design, the modeling tool that is used is called the structured chart. Just like during the structured analysis phase, we use modeling tools like DFDs and entity relationship diagrams. During the structured design phase, we use the modeling tool called structured charts. These structured charts are used to illustrate software structure to fulfill business requirements. So basically the job of the structured charts is to illustrate what would be the structure of the software so that you can fulfill, and this software is basically helping in fulfilling the requirements of the business. Structured charts describe the interaction between independent modules and the data passing between the modules. So basically all the modules in the system are independent. The functionality of one module does not affect the functionality of another module. That is fine. But still they are coexisting in the same system and they are working together to achieve the goals of the same system as a whole. That means there must be some interaction between those independent modules. So this very interaction is described by the structured charts, and it also shows that how the data is passing between what modules. So that means when I say data passing between modules, that means which module's output would be used as input by which module. In structure chart, the whole application is divided into modules, right? So basically, as I said, the whole system is divided into subsystems to reduce the complexity or design complexity of the system. So to cater to those subsystems, we have modules. There is for every subsystem there is a module. So that means the whole application is divided into modules, and these modules are nothing but the set of program instructions, because each module in itself is a software and the software is nothing but the set of program instructions, and modules are designed according to some principle of design, and there is a specific principle of design that should be followed for all the modules of the same information system. So all these modules are designed according to some principle of design. Now, what are these principles of design? These principles are, the first principle is modularity and partitioning. Now, modularity and partitioning principle says that each system should consist of a hierarchy of modules. We have modules for the system, and all these modules should follow a specific hierarchy. So basically the hierarchy is such that the lower level modules are smaller in scope and size compared to the higher level modules. Whatever the lower level modules are, their scope is smaller and their size is smaller as compared to higher level modules. And in hierarchy, we have the lower level modules, the higher level modules first, and then the lower level modules. The next principle for designing modules is coupling. Coupling says that modules should be loosely coupled. When I say modules should be loosely coupled, it means that modules should have little dependence on other modules in a system. As I said, they are functionally independent. That means the amount of dependence upon modules is very less. So this should be kept in mind while designing modules, that they should be loosely coupled. That is, all the modules of the system should have very little dependence on other modules of the same system. The third principle of module design is cohesion. Cohesion says that modules should be highly cohesive. So it means that when I say highly cohesive, it means that modules should carry out a single processing function. So although the modules are independent of each other, but still they are working towards achieving the same goal. So that means they should carry out a single processing function. They all should work towards a single processing function. So coupling should be loose. That means modules should be loosely coupled, but cohesion should be high. That means modules should be highly cohesive. The fourth principle of design for designing modules is the size of the module. When I say size of the modules, that means the number of instructions contained in a module should be limited so that the module size is generally small. So see, module is not a physical entity whose size would be defined by its dimensions. Module is a software. So how would you determine the size of the module? It would be determined by the number of instructions that are there in the module. So when I say the size of the module should be limited, that means the number of instructions contained in the module should be limited, which makes the module size small. The fifth principle of design for modules is shared use of functions. Now, functions you must have studied earlier also, and the sole purpose of having functions is that we do not have to write the same piece of code again and again. If the same piece of code is utilized by several modules, then that piece of code should not be written again and again. It should not be repeated in every module. There is no point of doing that. That would be sheer wastage of time. So why write the same code again and again if it is required by different modules? So if there are multiple modules which require the same functionality, which have a common functionality, so to achieve that common functionality, we can write a function in which a piece of code is there which is used by several modules. So this same functionality required by all the modules can be achieved by using a single function. That means they can share a function. Function, you all know, consists of piece of code which performs certain functionality, and which when required more than one modules is then in those modules then invoke that function. So function should not be duplicated in several modules. The same piece of code should not be written in several modules. Right? This function can be shared. It means that functions can be written in a single module. You can have a separate module for function for a particular function. Say for example, all the modules are doing their independent tasks. That means they have different set of instructions, but at the same time they all may require some common functionality. So to achieve that common functionality, you do not need to write the same piece of code again and again in all the different modules. What you can do is that you can create a separate module for that common functionality, which would be called a function, and then all the modules can invoke that particular function, which is again a module only. That function is also a module, and this particular module of the function can be invoked by any other module whenever needed. So these are the 5 principles of designs of modules, which say that a module the module should have modularity and partitioning. Then it should be loosely coupled, it should be highly cohesive, and the size of module should be small, and very important thing that all the modules must make use of shared use of functions. So this is the model driven approach, or the structured analysis and design approach, through which you can develop an information system.